Hello, this is Professor Navabi, and we are doing a very elementary course on digital logic circuits. A follow up of this course would be on describing elementary digital circuits in Verilog. In this course, though, we will only cover the very basics. We talk about gates, we talk about memory elements, and we talk about putting a few gates together and memory elements together to build very simple circuits. This is the a brief course description here where we talk about elementary gates and then talk about putting the gates together into combinational circuits, which are the circuits with no memory. And then we talk about building memory elements and then using those into building circuits, sequential circuits that are the circuits that remember something from the past, meaning that they have memory, they have a history that they remember. And we talk about finite state machines and so on. Some keywords: finite state machines, Carnot maps, Boolean algebra, flip-flops. These are things that we will be covering over here. So we start with number systems and then go into the binary arithmetic, adding, subtracting, and so on. And we talk about fractional numbers. How do we represent numbers in binary, which is the base that we use for digital circuits, zeros and ones. And then we go into logic structures like a simple AND gate, OR gate, and so on. Then Boolean algebra, which is the algebra for manipulating digital expressions or logical expressions. Carnot map is a more structured method built on top of Boolean algebra, which we will be discussing. Don't care values, we will get to that. You'll know what that is when we get to it. For now, then we talk a little bit about how do we build upper level circuits, more advanced circuits. Just a glimpse of that. We are really not going into high level design in this course, but we will say a little bit about it so that you get a picture for some future courses. Storage elements that are called latches and flip-flops. These are the memory elements that we'll be using in sequential circuits. Those are the circuits, like I said, with memory. The course is approximately 6 hours, and the way the lectures are arranged is, for example, we have number systems is topic A, and then we have A1, A2, A3. These are the segments of the topic, which I try to make them all under half an hour. And so, for example, A1 is 22 minutes, and we talk about decimal, hexadecimal numbers, and so on. And A3 is the last part, which we talk about floating point numbers and fractional numbers. Topic B is on basic logic structures, gates, and so on. And notice again that we have B1 and B2, 21 minute 31. Designing combinational circuits, we talk about Boolean algebra, we talk about Carnot map, we talk about iterative circuits, and these are the timing of each of these videos, C1, C2, and so on. Topic D is on storage elements. Those are the memory elements. Storage elements, which we talk about latches, flip-flops, and so on. This is where the concept of clocking comes into play. Topic E is on sequential circuit. These are circuits that remember something from the past, and these are the 3 lectures there, E1, E2, and E3. Here we'll be talking about how to describe a circuit, how to turn it into gates and those memory elements, and actually how to build a circuit that does remember something from the past. This is it, and all together we have 6 hours, and enjoy the course. And like I said before, a follow-up of this course is on Verilog, and we'll be discussing Verilog description for all these little circuits that we do over here. Thank you, and enjoy the course.